Let's continue with our sixth tutorial, raster operations, and now we start with zonal operations. So I want to remember that zonal operations actually work with each pixel value. For instance, in our case, in soils, 4 pixel values, right? 4 classes, and in LULC 7 classes, etc. So activate data frame zonal, calculate elevation statistics as table for every soil type. Use soil type as zone field, chart the mean statistics. Okay, and here we can find zonal statistics toolset in spatial analysis tool. So we need zonal statistics as table. So we have actually 4 types of zonal operations here. A zonal geometry first, when we achieve an output dataset with calculating geometries for zones. Also zonal statistics, when we also achieve an output spatial dataset but with statistical measurements, and we also have zonal geometry as table and zonal statistics as table when we achieve a table as an output. So here we input raster of feature zone soils. Here we have soil types, right? And input value raster is elevation. So for soils, for each class of soil types, we calculating elevation, mean elevation, right? So let me just, I'll print screen it and just put it here. Okay, let's click OK, and here's calculating a table. So we can delete here. So now we have a table as an output. Can clip it here. What does let's put it here, okay, in A, B. So here we have a table, soil types, zone code, number of pixels, area, and mean. It means average elevation for each of this soil type class. For instance, we can just peat soil, right? Peat soil is the first class value. Here, peat soil, it's here, right? So for this soil type, we have an average elevation of 8.6 meters. While for a clay soil, we here can say clay soil, right? This area has on average a very high elevation. It's more than 33 meters. So the question, what does a record in the statistics table represent? So in the statistics table, each record, as I mentioned, represent can just represent a class of a pixel, right? Because one value, it does represent the pixel class, right? Or pixel value. So pixel, each value here in an attribute table represent a separate pixel class in our discrete pixel raster. What is the average elevation of a clay soil? So we open again our table, zonal statistics, and the clay soil is average elevation is 33.5 meters. What does scale or measurement scale should data have to calculate statistics? What does a scale or measurement scale should data have to calculate statistics? So we'll talk about it more precisely and more deeply in one of our tutorials, which will be concerned the map presentation, and we will talk about 4 measurement scales: nominal, ordinal, interval, and ratio. And I already mentioned that in general in ArcGIS we work with 2 types of data, quantitative and qualitative. So statistics should always have statistics are always works with quantitative information. That's why the statistics discipline intended to do. Calculate land use statistics for every soil zone. Use again soil types as zone fields. So we again use zonal statistics as table, right? We can also use zonal statistics, but we don't need this now. But the result will be not only the table but the spatial data set. So input raster. So the calculate land use statistics for every soil zone. So okay, we again click here soils, soil types as zone field, and here is land use, land cover map, and we put all here, all statistical types, which will include mean, majority, maximum, medium, etc. So let's now see what we will achieve. So again, open the table, see that we have the same soil type classes, zone codes, counts, area, and we also have these statistical indicators, minimum, maximum, range, etc. What does this represent to us? Actually, it doesn't represent anything, because we here combined two types of discrete rasters as inputs, right? Soil types and LULC. So we're calculating statistical indicators for each soil type, where as a second input raster we took land use classes. So what can these attributes mean? This mean actually nothing, just useless information, because for zonal statistics, if we take one input as discrete information, discrete raster data, which has mostly qualitative information here, like soil types, right? Second raster should be should have quantitative information like elevation. But when we take as a second raster also raster which has qualitative information like land use classes, right? It will still calculate the statistics, but the statistics doesn't mean anything for us. Doesn't have any sense. What does a record in the statistical table represent? Well, actually, we already answered to this question, right? So we don't need it. Each of the attributes of the statistics table gives relevant information. Explain your answer. No, this time, because because for both input rasters, for zonal statistics, we used qualitative information, while as we should use as for second input raster quantitative data such as elevation, right? For instance, like we did before. So the question 7, calculates the areas of land use zones by using zonal geometry as table. So now we will use the second type of zonal operation, zonal geometry as table, and join the output table to the original data set. So let's go back and open zonal geometry as table. Here we have land use and land cover, and for each land use class, right, land use zones or land use classes, zones and classes and values are the same thing here. So just I write zone classes class and the value.